Welcome to this Maths Made Easy video on vector basics. So to start with, let's just discuss what vectors represent and what they are. Now a vector contains both size and direction, so let's just note this down here. So a vector contains size and direction. Contains size and direction. So for example, a velocity of 5 meters per second on a bearing of 120 degrees would be an example of a vector. And we can see here from this diagram on the right, this represents a vector, and they're simply drawn as lines with arrowheads drawn on them as well. Now the magnitude, this represents the size of the vector, that's expressed by the length of the line, and these can sometimes be drawn to scale. And for the direction of the vector, this is simply shown by the direction of the arrow. So that gives everything we need for introducing vectors there. Moving on now to take a look at finding resultant vectors. Now vectors can simply be added together by drawing them, then the single vector that goes from the start of the first vector to the end of the final vector is known as the resultant vector. So if we've got this diagram here, if we say this is the vector A here, and this is the vector B, in that case, R is simply equal to A plus B. Okay, so this would be the resultant vector here. So therefore, R is equal to A plus B there. Okay. So we can see to get to the end point of R, like we just said there, we simply go along the vector A here, and then go along the vector B. Okay. Now the order that you add the vectors in doesn't matter. The resultant vector is always the same, and we can see that from this diagram here. Okay, so again, it just illustrates the same idea here, but just also shows that the order we add the vectors in does not matter. So that gives everything we need there for finding resultant vectors. Moving on now to take a look at subtracting vectors. So subtracting a vector is the same as adding a negative vector. So using this diagram here, if A is a vector, then minus A is a vector of the same size, just in the opposite direction. Okay, so we can see that here. So A goes in this direction, so minus A is the same size, but it just goes in the opposite direction. So in that case, subtracting a vector is the same as adding the negative vector. So for example here, A minus B is simply equal to A plus minus B there. Okay. And we can see that from this diagram here. So that gives everything we need there for subtracting vectors. And finally, let's take a look now at multiplying vectors by scalars. So when you multiply a vector by a scalar, and remember a scalar is just simply a numerical value, this changes the length of the vector. But it has no effect on the direction. So if a vector is multiplied by a non-zero scalar, the new vector is always parallel to the original vector. So for example, A is parallel to 3A. So in that case, to show two vectors are parallel, you need to simply show that they are scalar multiples of each other. So in that case, let's take a look at this example here. And it's quite a lengthy example here. So we've been given the vector AB is equal to X, and the vector BC is equal to Y. We're told the point M lies on the line AB and divides the vector AB in the ratio 3 to 2. N lies on the line BC and divides the vector BC in the ratio 2 to 3. So here we want to show that the vector MN is parallel to the vector AC. So first here, what we're going to do is just consider the ratio that we're splitting these lines up into. So here we know the point M lies on the line AB and it divides the vector AB in the ratio 3 to 2. So what that tells us here is that M is 3/5. So M is 3/5 of the way along the vector AB there. Okay. So therefore, what we can say then is the vector AM is simply equal to 3/5 of the way along AB, the vector AB here, so that means it's 3/5 of X. Okay. And in that case then, the vector MB, so the vector MB here is simply equal to 2/5 of x. Okay. Well, in that case, considering now the point n here, which lies on the line BC, and divides the vector BC in the ratio 2 to 3, again, considering this in the same way that we did here for m along the line AB, then we can see n is 2/5 of the way along vector BC here. Okay, so in that case then, the vector Bn here is simply equal to 2/5 of y. Okay, so what we want to show here is that the vector Mn is parallel to the vector AC. Well, in that case, the vector Mn, so therefore the vector Mn here, will simply be 2/5 of x, so it's going to be MB, so 2/5 of x plus 2/5 of y, so that's going to be plus 2/5 of y. Okay, and here we could factor out this 2/5, this 2/5, to give us 2/5 x plus y there. Okay, now what we want to show here is this is parallel to the vector AC. So in that case, taking a look now at the vector AC here, well, in that case, we know the vector AC here is simply equal to x plus y. So if we just do this in the top here, just so we can see it clearly, the vector AC is simply equal to x plus y. So in that case then, if we take a look at these two vectors, what we want to show here for Mn, or the vector Mn to be parallel to the vector AC, is this is a scalar multiple here. Well, we've got an x plus y here times by 2/5, and for the vector AC, we've got x plus y. So in that case, what we can see here, that 2/5 of x plus y is equal to 2/5 of the vector AC. So therefore, the vector Mn is equal to 2/5 of the vector AC here. Okay, and in that case, it shows that the vector Mn is parallel to the vector AC. So therefore, we write this out in full. Vector Mn is parallel to the vector AC there. Okay, so that gives us everything we need there for multiplying vectors by scalars, and that concludes this Maths Made Easy video on vector basics.